8.7, we are sketching quadratics, but what do you guys notice about the title of this one? Factorable. So this should actually be reviewed. This is what we did in unit, what was factoring? 5? The last lesson of unit 5, remember? Okay. Okay, so we have some steps first that we need to go over and review before we can start factoring and graphing these things. Step 1, we're going to factor the quadratic. What are our different methods of factoring? Carlos, what's one? The diamond method. Bottoms up is another one. Difference of two squares. Perfect square trinomial. And GCF. Good. So we had 5 different ways of factoring. Should we list those? Let's list those. Factoring methods. I know. But you don't take the poster home with you, do you? Okay, first factoring method is GCF. Second factoring method was difference of two squares. So, after difference of two squares, we had a special case, our perfect square try. We're just abbreviating. 4 was Carlos's favorite one, the diamond method. And then if all of those didn't work, we used bottoms up. Okay, so we just are listing our factoring methods just so you remember, because this is going back to quite a while ago. Okay, so when I'm solving these things, after I factor, I need to set the whole thing equal to what? Good, 0. So you set the entire equation equal to 0. That's step 2. Step 3, we take each factor, everything that's in a parentheses, and sometimes if we use GCF it's not. We're going to set each factor equal to 0 and solve. Does anybody remember what that is called?
Zero product.
Good job. 0.
Good job, Alyssa.
Product. Property. Okay, so the 0 product property means that all products are equal to 0 if the entire answer is equal to 0. Or each one can be 0. Okay, step 4. We're going to get 2 points as our answer, which are the x-intercepts. So we're going to plot the 2 points. Or actually, let's call them x-intercepts. Plot the 2 x-intercepts.
Is that a B?
There's no answer.
What?
There's no answer.
Well, because we're setting x equal to 0 or y equal to 0, we're only finding the x-intercepts here.
Oh my gosh.
And then we are going to sketch the graph. Now remember, with sketching, I'm going to have you underline this. If x squared was positive, the graph opens up. If x squared is negative, the graph opens down. Okay? Example 1. Our instructions here are to sketch the following on the graph. Label the x-intercepts. Okay, is this thing already factored for us? It is. So we get to skip step 1 and go straight to step 2, which is we set the whole thing equal to 0. So this is 0 equals x minus 1 times x plus 5. So because we're plugging in 0 for y, we're automatically getting the x-intercepts. Okay, and then what do I do? Draw the line down the middle and set x minus 1 equal to 0 and x plus 5 equal to 0. X minus 1 equals 0. I add 1 to both sides, so x equals 1. X plus 5, I subtract 5 from both sides, so x equals negative 5. These are x-intercepts because y is 0. We plugged in 0 for y. So is it going to be touching the x-axis or the y-axis? The x. So let's graph positive 1 first. That's going to be right here. And then negative 5. 1, 2, 3, 4, 5. And we are just sketching, so our graph does not have to be 100% accurate here. Is it opening up or down?
Down.
Up. There's no negative outside, right? So it is opening upwards. Yeah. Do you guys remember this?
No.
This should be review from like December. No, just draw it a little bit bigger than the lines. Or than the dots, I mean. Okay, so example 2 then. Is it factored for me?
No.
Actually it is. Everything's broken up, right? So we're going to set the whole thing equal to 0. So 0 equals negative times x plus 3 times 2x plus 10. Set each one equal to 0, so that's x plus 3 equals 0. And 2x plus 10 equals 0. X plus 3 is pretty easy. What do I do there? Subtract 3. So x equals negative 3. Okay, what about the right hand side? Subtract 10. So we get 2x equals negative 10. Now I'm not done yet. Abby, what do I have to do? Divide by positive 2. So x equals negative 5. Yeah. Okay, so let's, these are x or y intercepts, guys? X, because it's x equals, right? So let's graph them. Negative 3, 1, 2, 3. And negative 5. So 3, 4, 5. This is a skinny one.
This one goes down.
Okay, is this one opening up or down? How do you know? There's a negative out front. So let's sketch it. This is a skinny one. Opening downwards. Okay,
What
now,
does that mean?
guys, example 3. Now this one is not factored for us already, so that's our first step we have to factor. What's my first step of this one? Factor. Carlos, what use? The diamond method. So let's draw our diamond.
Oh, I remember.
If you can do it in your head, don't worry about it. It also is a perfect square trinomial. You can use diamond method though also. So two numbers that multiply. Oh no, this is not a perfect square trinomial. I'll show you.
So whenever you're using a factor, you always use diamond?
Not always, but for this one, yes. Okay, what are two numbers that multiply to 4 and add up to 5?
Negative 1 and 4.
1 and 4. So is it a perfect square trinomial?
Yeah.
No, because this is x plus 1 times x plus 4. So they're not the same. If we wanted this to be the same, it would have to be 8. Yeah. Yeah. Okay, so the middle would have to be 8. Perfect square trinomial is if it factored to x plus 4 times x plus 4. Which means the middle two would be 8x, right? Because 4 plus 4 adds up to 8. Okay, so we factored the whole thing. Now what? What's step 2? Set it equal to 0. So 0 equals x plus 1 times x plus 4. And then I set each factor equal to 0, right? So I always draw the line down the middle. X plus 1 equals 0. X plus 4 equals 0. Left hand side, subtract 1. So x equals negative 1. Right hand side, subtract 4. So x equals negative 4. Question, are these x-intercepts or y-intercepts? X. So let's graph those. There's a negative 1 and a negative 4. 2, 3, 4. This is also a skinny one. It's opening up. How'd you know? Because x squared is positive, right? We're looking at that x squared term. It's not negative. Because it was negative. there's a negative on the outside. So we draw it opening upwards. Make sense? Yes? We will skip number 5 if everybody gets number 4 correct. So I want you to try it by yourselves. It's exactly the same, there's just a negative on the outside. Still use, if you want to use diamond, go ahead and use diamond. This one should be a perfect square trinomial.
Do you have to distribute them?
Alright, so this was, you can use diamond method, 2 numbers that multiply to 9 and add up to 6, 3 and 3. Some of you recognized that it was already a perfect square trinomial right off the bat. So I set the whole thing equal to 0, and we could actually write it as x plus 3 squared, right? Okay. Now we set this factor equal to 0, correct? So how many times do I have to write x plus 3 equals 0? Just once, because if we write it twice we end up getting the same answer, right? So subtract 3, so x equals? Negative 3. So my x-intercept is negative 3. 1, 2, 3. How many times does this graph touch the x-axis? Just once. Is it still a parabola?
No.
It is, because it still has an x squared. Now, so what we do here is, it's the only thing that this is saying is that it only touches the x-axis once. It's still a parabola. Is this one opening up or down? Down. So this one point is actually just the tip of the parabola. Oh, so it's still a parabola because it's an x squared. It's just only touching the x-axis once. Okay? So we'll do it. So what do you think would happen if I never get an answer for this part? If it never touches the x-axis, is it still a parabola? It is, it just never crosses the axis. Okay?
Oh.
The answer is just telling you how many times it crosses the x-axis. It doesn't mean that that the graph doesn't exist at all. It just means that maybe those intercepts don't exist, which means it's not touching the axis. So you could possibly get one if you get no answers when you set it equal to 0. It just looks like this. It just never touches. Does that make a little bit more sense? Okay. What you're going to be working with on your homework is it either crosses twice or it crosses once. So you're either going to be getting parabolas that look normal, cross the x-axis twice like this, or like what we just did in example 4, only cross once. Okay? So don't freak out if you don't get 2 answers. How many factored this using diamond method? Raise your hand. How many realized it was a perfect square trinomial? Okay? So this is a perfect square trinomial. So we would get x minus 5 squared, right? Even if you use diamond method, you should have gotten this. Okay, so we set the whole thing equal to 0. Now, how many times do I have to set x minus 5 equal to 0? Just once. Add 5 to both sides. So x equals 5. So that is at 1, 2, 3, 4, 5. And is this one opening up or down? Up. Because that middle term is negative. So what do you guys think about perfect when it factors if it's a perfect square trinomial? It's always only going to touch how many times? Once. Okay? So if you can factor it and it's a perfect square trinomial, it's only going to touch the x-axis once. Okay?